Hello everyone, welcome to Computer Science and IT Gate Coaching. Don't forget to subscribe my channel and press the bell icon to get the instant notification of my free lecture. Now see, Gate 2020 question for 2 marks. So it is saying that consider the following language. The language is containing X. X is your the string. Here they are representing X as the string. Belongs to A, B star means any combination of A, B. So string belongs to any combination of A, B such that number of A's in X divisible by 2. Number of A's in X divisible by 2 but not divisible by 3. So number of A's in X will be divisible by 2 but not by 6. Like if you are having some number like 2, it's only divisible by 2. 6 is a number which is divisible by 2 as well as divisible by 3. So this number of A's like 6 A's is not allowed in this. 6A is not allowed in this language because it is saying that number of A's in X divisible by 2 but not divisible by 3. Here it is both divisible by 2 as well as 3. So this string not belongs to the language. And here they are not saying anything about B. So you can have any number of B here, then here or here. So in between any's A's we can have any number of B's. So we are not having concern in number of B's. So we can have any number of B's either first day, after first day, after first, before first day, so before second day. So our main concern here is just to focus on A's and we have to see whether it is divisible by 2 and not divisible by 3. Now if you are having, now how to find that the number which is divisible by 2 and 3. Now we will find as a reverse way we will do. So you know that if we find the LCM, we have seen this kind of problem, if we find the LCM of 2 and 3, it is going to give the least common multiple. So LCM of 2 and 3 is 6. It means the number which divides 6 are the numbers are divisible by both 2 and 3. Like if you write 0, 0 is divisible by both 2 and 3 because it is divisible by 6. Then 6, 12, 18, 24, 30. So the numbers which is divisible by 6, it means it is divisible by both 2 and 3. It means it is divisible by both 2 and 3. So what we will do, we will construct a minimal DFA which is divisible by 6 and we will not make Q0 as the final string, remainder is 0 because we don't want that it should be divisible by 6 because we want only the numbers when it is divisible by 2 and when it will be divisible by 2, if you take any number like 8 divide by 6, you will get remainder as 2. Take 12, divide by 6, you will get remainder as 0. So it means it is divisible by both. Now take 10, divide by 6, you are getting remainder, means it is divisible by 2. So when you are dividing any number by 6 and you are getting any remainders, and if remainders is divisible by 2, it means that number is divisible by 2. Okay. So what we will do, we will construct a minimal DFA for divisible by 6. And whenever the remainders are divisible by 2, that state we will make as the final state because we want only the state which is divisible by 2 but not by 3. Okay. Now see, we will construct the DFA. So here it is saying that the minimum number of states in the DFA that except L. So they are asking what is going to be the minimum number of states in the DFA. You know that minimum number of states in DFA is equal to minimal DFA. So we are going to construct a minimal DFA. So how we will construct? So initial state Q0. Okay, then by getting A, we are going to another state Q1. This is saying that remainder 1, this is saying that remainder 0. Now by getting another Q2. Now by again getting a Q3. Now by again getting a Q4. Now by again getting a Q5. So you are going, when you will divide anything by 6, you are going to get 6 remainders. 0 to 5, so that's why I require 6 state 0, 1, 2, 3, 4, 5. Now again if you will get another A, then number of A will become 6 and when you divide by 6 you will get remainder as 0. So you will come from here. Now you know that here we are just concerned on number of A's in X, not number of B's. So what we will do, if we will get any number of B, we will remain there. We are not counting B's, so we will just keep a loop of B. Keep a loop of B. Now see here, they are saying that number of A's in X divisible by 2. So if you are getting remainders, which is divisible by 2, it means that number is divisible by 2. So like q2, you are getting remainder 2 divisible by 2, 4 divisible by 2. That's why we will make this state and this state as final state. We will not make q0 as final state. Why? Because q0, if we will make q0 as final state, it means the number is divisible by both 2 and 3. That's why it is divisible by 6. If any number is divisible by 6, it means it is divisible by both 2 and 3. So, and when you will get remainder 3, like 9. So, if they will change the question, so if you will just interchange it, like if you will say that divisible by 3 but not 2, then if you are getting 9, then you see this is divisible by 3 but not divisible by 2. Because if you divide by 6, you are getting remainder as 3. So, by changing the question only, then you have to change the final state. If you want only to accept the number which is divisible by 3, not by 6, then you have to make q3 as the final state. And many things we will see, but we are not going there. So you just have to see, whenever this kind of question they are asking that divisible by 2 but not by 3, then you need to find the LCM. That you have to first find the numbers which is divisible by both. So if they are saying divisible by 2 as well as 3, okay, both, now I am changing, both are divisible, then 6, if it is divisible by 6, then. So this kind of questions we have seen in sigma when sigma is 0, 1. For this kind of question, how to approach? First, I am just giving you a summary. First, to find the LCM of both. So it will give you the number which is divisible by both. Now, if you want to accept just like divisible by 2 only, then if you will get whatever remainders is divisible by 2, then you make that state as final state. Because it is saying that that number is divisible by 2. Now, if you want to accept the number which is divisible by 3, okay, so whenever you are getting any remainders which is divisible by 3, then make that state as final state because it is saying that that number is divisible by 3. But here you are not required to construct a, see, this I have explained you because it will give you an idea if I change the question. But in exam you don't need to do this thing. Just by seeing the question you understood that we have to find the LCM. So no need to construct. Just they are asking the minimum number of states in DFA that accept L is. So you know that it will take LCM. So 6 is the LCM. So 6 is the answer. So 6 is going to the answer. It is going to 2 marks. So you will get in 10 seconds. You will give the answer. So because if you are having a very good practice, just by seeing that you understood, yeah, we need to find the LCM. No need to construct. In exam, no need to do all this thing. Just to explain you, I am drawing the diagram. Okay,